Okay, happy Saturday morning. So, the stream I did yesterday, I actually forgot to turn off my music on my computer. So it got like partially banned because it was listing like 20 different songs or something. Mm. So, yeah, that was unfortunate. But luckily, my channel didn't get banned. Okay, but I had a lot of reflections yesterday, and I built something in the evening. Um, and this morning, I wanted to show you because there's this question of like, I'm like I haven't looked much into the React compiler, but we did that yesterday, and I'm like thoroughly. It makes so much sense to me what it's doing. Uh, and I think it's often been interpreted as like just automatically going in and using memo and using callback and stuff, but it doesn't do that. It like analyzes your props and state usage, and then it just creates this like super efficient optimal cache that goes through the whole. It's almost like it splits your component into different parts based on what props and state that part actually needs, right? So it's very, very impressive work that they're able to do that. But the really interesting thing is that, as I mentioned also, like, does it wrap everything in memo? What happens there? Like, the thing is, it doesn't even use memo. So instead of like putting memo on the component where you define it, it's rather at the consumption. Like you have all these different parts, and if one piece of JSX is using a component where you're passing props or state, it's gonna just shove that into its own cache so that it will only like remount that component or kind of bring that new component version into the virtual DOM if the related props and state has changed. So it's like incredibly efficient. And it brings in like, it makes React behave like you want it to behave in terms of rendering, right? You should only reconcile components where state and props actually has changed. And it does that just out of the box. And then, so what happens is that instead of like going through, let's see, oh, instead of going through, there we go, and make like everything reconcile, if you make a change at the root, it just optimally, like when you pass things as props or state as props, it will just optimally find one path down to the state that's actually consuming that change, right? That means it will still reconcile kind of unnecessarily, like in this example where we're flipping the to-do. So like it doesn't really need to reconcile root, list, to-do. It only needs to reconcile the actual, like this represents like toggler or something. So it only needs to reconcile that toggler. But what happens in reality here is that it will not reconcile anything else than specifically the list inside here. Like most of the stuff returned from root is the same, is cached. The only thing that's changed is the actual list component reference because the state actually changed. So that's the only thing. And then it goes into list, and then everything's cached except the thing that like goes through the list, and then the specific to do that. Yeah, that's something we can actually check. How does it manage lists? So it makes sense that it runs through the list again, but how does it actually cache that? Because one thing is like the root, it's caching the list itself, but here you have like any number of to-dos. So I'm interested in how it does that. So let's actually create that. So we have a to-do component, which takes like a to-do, whatever, to-do, it doesn't matter what we write here. And then we have the app, and that to-dos, set to do's, use state. And now we're going to iterate this thing. And let's see what happens. So ul to do's map to do return to do key to do.id, and then we pass the to do in there. Let's see what happens. What does it actually do? So it maps over to do's and creates to do's. And then it has a temp. But what does it do with the actual to do here? Because what I think happens there is that else t1 equals cache1. Okay, that's interesting. So what I think actually happens here is that it does indeed go and try to reconcile all the to-dos, but instead of like doing a props check, this is very interesting. So when you have a memo, like if we had a memo to do, it would do like a props comparison first, and then it would decide to reconcile, right? But here it actually goes straight in and reconciles all the to-dos, but it's basically doing the same thing, because we're going to return the same virtual DOM node here, because it hasn't changed the title, right? So it is kind of doing the same thing. But it's very interesting, like how it shifts your perspective on how to optimize this. It's very cool. Anyways, so the point is that it, because we think about reconciliation as like recomputing the whole component, right? Like it actually needs to run through all the logic of the component. It's returning a completely new virtual DOM node, and it needs to do a lot of comparisons, right? And that is how it works. But here, it's way more efficient. So it's very, very interesting. What I also wonder is like how it does. Yeah, whatever. That was sidetracking. The question is like, does this mean that also when React was first introduced, it was introduced as this top-level, top-down reconciliation, right? You change the state at the top and then you reconcile the whole thing. But then that wasn't really true, because if you define, for example, your to-dos in the list and you change within the list, of course, it will only reconcile from the list and down. It doesn't reconcile the whole thing, right? But that's the thing about complex applications, is that we have most of our state like lifted up quite high in the component tree, or they need to be quite high in the component tree so that other components can actually consume it. Or the relevant components can actually consume it. So then that becomes like a huge ass problem. Like it works just fine with React as long as your state it's like how many components are involved in terms of hierarchy. But as soon as like this becomes bigger and bigger and bigger, more and more components are. Yeah, our 4-year-old is having a hard day. It's literally here. Like if the toggler was the only thing, well, that's where you actually had the completed state. Toggling that would only happen in the toggler. But then as your complexity increases, well, actually in the to-do, we want to indicate if it's completed or not, for example. And in the list, we want to filter on the completed state. And then, we need it at the root because there are other components that also needs to know about these to-dos and their completed state, right? So you just keep lifting a lot of state up, and it just hurts performance more and more. But what if that wasn't the case? What if you could have like all your state at the root? And because of the React compiler, it's so efficient at finding the path to the components and diving through that path. It does so minimal work because of caching that it doesn't matter. And I remember talking to some people there's a service called Scrimba. It's actually really cool. Scrimba.com, I think. Oh, they changed the website. They're using a language that one of the founders built called Imba, and it has its own like kind of virtual DOM tree, but it's called like a memory DOM or something. But it does this. It does reconcile everything from the top every time. And it's super fast, but it's because of kind of like the caching, right? So this is why I have like high hopes for this, because I know there are solutions that's able to do like this full on, just look through everything, but because of caching, it will just be insanely efficient. But what does that mean for state management? So what typically we do for state management is that we define it globally, but we consume it at different points in the component tree. And there are different ways to do this. So you can make like each component subscribe to a global store, for example. You can expose your root state or your state at the root of the application through a context, for example. And then there are observers, so it's observation based instead. So it's kind of implicit subscriptions by accessing certain state. But with the React compiler, we can think about this in a different way. What if we again expose all our state at the root? But what you get out is actual just normal immutable state. And we rely on the efficiency of the React compiler to manage the performance. Hei du. Skal du være med mamma ut en tur? Ble du sint? Ja. Men vi hadde en avtale, Oskar. Ja, jeg skjønner at du blir sint. Men det er viktig at vi gjør litt forskjellige ting, ikke sant? Nå hadde jo vi en kjempegod plan. Ja, men nå kan du gå opp og kle på deg. Og så kan du ta en tur ut med mamma. Og så skal vi dra alle sammen etterpå på senteret. Det blir bra det, skjønner du. Yeah, so let me show you like a tiny demo of this first. Oh, yeah, I have to build the thing. Oh, come on. Du, Oskar. Det er veldig viktig at vi gjør det her, så alle får gjort det de har lyst til, ikke sant? Nå hadde du lyst til å game, og nå har du fått lov til å game. Og nå har pappa lyst til å gjøre det her, så da kan du ta deg en tur ut sammen med mamma, og så drar vi alle sammen på senter. Ja, men da må vi gjøre sånn, ja. Okay, so I'm gonna try to explain this. Let's see. Hvit yarndev. Like try in the sense that I have a by the way, the lights are a disco ball thing. So okay, so let's look at the actual app here. Like it's of course very simple, but it's just so you get an idea. So we have we have this app wrapper, and we're creating some state, and then I'm creating a subscription to that state and passing it into this hook. Like this could be different. It all can happen like more in one go, but it's just to explain what happens. So we can talk about these subscriptions later, but the point is we have an app wrapper that takes the counter, the root state, and then in the app we're just running this effect. So whenever the nested count changes, by looking at the nested object, we log out something and then we pass the counter down to deeper. But we also have another component that's a nested component that doesn't take any state. Oskar, nå må du må komme i gang med dagen din. Leo, nå må du komme i gang med dagen din. Ikke slå meg. Jeg er lei for det, Oskar, men du må komme i gang med dagen din. Oh my god, sometimes these kids can be amazing, but especially in the weekend, they're like so fucking tired from the week. And like they sleep in every weekday and then they wake up early when it's a weekend. And then like having a 4-year-old is quite exhausting because they can't like run around on their own. They constantly need like supervision if we're outside. And like we're just not good at sharing. Oh my god, I got winded. Yeah, sharing responsibility with the neighbors. Like we're starting to, but it's like, yeah, so either me or my partner has to like attend to him. And normally that's fine if he's in a good mood, but if he's in a shitty mood, like everyone's in a shitty mood. Anyways, let's get back to it. Yes, and then we have this nested component, right? So, and then we're running through these items. So the point is when I render this, it renders the app, deeper, and nested. But when I change the count, it's only app and deeper that renders or reconciles. And that's because the app, of course, uses the counter and passes that down to deeper. But nested doesn't need this state. So it doesn't do another render or reconciliation for it. So it does exactly what you think it should do. But the point is that the cool thing about this now is that Bonsify is still like the same thing. Like you use it the same way. Sorry, where's the counter? So we have a counter. I'm just calling it state now. And you define everything exactly the same way. There's no change to this, though you don't have to implement read-only. Because what actually happens here is that in these proxies, so every object and array has a wrapping proxy, which is mutable. And that's what's being used here inside your state management. But then when it's exposed to React, there's an immutable version of that state. That's like just a pure objects and arrays, right? That's being managed inside the proxies. So when you're actually exposed to state to React, you get that immutable version for value comparison, and there aren't any proxies anymore. So here you are in proxy world to efficiently do like mutations and just write code as you normally do. And then for React, it's just plain objects and arrays, and they don't affect each other, right? But another cool feature of this is that you can actually like subscribe to any proxy. So I'm just subscribing to the root level object, but you could technically subscribe to whatever you want there. So that's a really interesting concept there, and the implementation is super simple. Like this is all there is to it. It's not like barely 150 lines of code. So that's pretty cool. But what I thought we could do is we're gonna really test this. And what we can test it with is, didn't I have it here? No. So ShadCN has this, yeah, tasks. So I wanna grab this. How do I grab this? Browse blocks. Okay, you know what? We're gonna actually take the whole freaking thing. npx ShadCN dashboard 01. We're gonna grab this whole thing, and then we're gonna do some crazy amount of updates to one of these, like changing limit or whatever, and just see like what actually happens, and see if we can figure out some performance stuff. So let's try to install this first. Yes. Yes. No. Oh. Let's do this first. Let's import Tailwind CSS. I didn't prep this, so we just have to do this together. There we go. Import Tailwind CSS. That would be here. Okay, let's try again. No. Oh yeah, here's the. So is this also? Oh, that's the tsconfig file. I guess I can use it here. Is this where it's going to be? Compiler options? No. Oh. There we go. And then tsconfig app. Oh my god. So this is inside compiler options. Cool. Update the Vite config. Ah. And we need, oh my god. Import path from path. Oh, yeah, whatever. And then, here add types known. There we go. Oh, let's see. Let's try again. Yeah, whatever. Okay, and then how do I actually use this thing? Oh, nice. Yeah, and then data. Okay, cool. Let's do this. Is there like an export default here? Yeah. Let's just do this, and then we have data JSON. New file data.json. So we're gonna use this later to kind of get the thing. Let's see what happens now. Seems to be loading. There we go. Nice. Okay, cool. So we got the thing. So what we're gonna do now is let's take a look at data here. So we have data table. Okay, so yeah, but this is also quite interesting. It's like the way this is architected or like composed. Architected is a strong word. But the way it's composed is that at this page, you actually have like the component for the data table, right? So it looks like this is very costly having like root state, but really isn't, because this data table is exposed at the root component itself. But we're still gonna test this, and maybe we can make it like more tricky. Like we're gonna actually gonna like put things more nested, so it's not composed in the page like this. But this is really how you should do it. So whatever. So let's do the same thing. We're gonna move this data. Let's just call it new file data.ts export function data. And what did the data look like? Was it an array? Yeah. So we can still import that data. Let's see, but we're gonna import it in this other thing. Import data, and then we're gonna say state, or sorry, JSON data. Data is state, JSON data, oncify, return data, and then we're just gonna have like a kind of a counter thing here. Let's actually give it a type. Data item number string oops, string. Now one thing that's interesting though, yeah, that's kind of unfair here, is the fact that well, actually React will also optimize. Oh, that's a good thing for ShadCN. Like it will actually go in. Oh, but that's going to be interesting if it's actually able to optimize the ShadCN components. But let's just finish this and then we'll see. Cool. And then so we're just gonna do it here. So this would be data would be data, and then we're gonna create a data subscription, create subscription for that. Create a subscription, create subscription. Ah, come on. It's just because of my linking. Create subscription, and then we're gonna just say yeah, by the way, we're gonna do this, and then data equals use subscription, data subscription. Okay, so now we still have our data, right? Yeah, it's a pretty hefty piece of UI. Looks amazing though. So let's have a look-see here. Let's have a look-see. So what we want to do, I'm gonna ask the AI to write this. Could you add an interval of 1 second which picks a random item in the data array, and let's make this a number. Let's see, JSON data. Oh, where's the data? Please make all limit values numbers. Wow, that took a long time. Hello, Claude. Is it too early for you? Maybe we can take a look at the actual data table component. Yeah, look at this. It's a pretty complex component, right? And this is going to be very interesting. Oh, look at you go. Oh, it was a pretty big table. But it's a really good example because it shows how composition affects like performance. Because what happens is when you do state management with a global store exposed on a context at the root, you tend to build your React components as like just nested into each other. There's very little composition happening, in my experience at least. So you have like one component, and then you have another component, another component, another component, as opposed to using children to actually compose it together like you see here. Like you would just have like sidebar. Oh, this is a provider. Yeah. So you have like app sidebar, and then you would have main, app main or something. And then inside app main, you would have header and like main section or something. And inside main section, you would like, so that's the way you would kind of nest it, which is not really what React encourages. Okay, now could you add an interval of 1 second which picks a random item in the data array and increases the limit by 1? Interesting, it doesn't understand. Oh, look at you. You don't have to do this. Let's just change it. It doesn't understand it. A random index limit plus plus. That's all you have to do, friend. And this is this kind of shows you why you might consider having mutable external state. So you can do things like this. Okay, this is going to be interesting to see if this actually works. I guess it's kind of hard to see. We should see one of the limits. Like there's 7 pages here. Okay, maybe we should just make it like super quick. Are we going to see any of them update? Okay, let's just slice to 5 of them just to see that it works. Oh, it doesn't actually work. What did I do? Is it because it's an array? Oh, interesting. Oh, is it because... Okay. Oh, for fuck's sake. Let's keep it as a string. This is going to be a string, but we're just going to limit equals number plus 1. Yeah, something like that. That's kind of weird, no? But yeah, I haven't like thoroughly tested this thing, so I might be messing up something. Let's see if it actually updates. Oh, it doesn't trigger changes. Oh, it does. But why isn't anything changing? Ah, this is gonna be... Okay, so we're... Wait a minute. Set timeout. 1 second. So 5. Why isn't it subscribing to it? Hey, what happened? Oh, did I stop? So initial render. I'm not sure which item it actually tried to change. Maybe we should look at that as well. It could be a problem with my implementation. So let's see. Updating 2. So that will be 0, 1, 2. So the limit here is 14. Wait, 14? Oh. Oh, I think I have a problem in my implementation. Oh, fuck. We have to fix that first. Yeah, because it changed it like this. It mutated the thing. I wasn't supposed to do that. I just made that change before the stream, and I messed up. It happens. Let's see if we can fix that. So, yeah, I wasn't sure if I should. Let's see. So we're bringing in the target here. And then we actually don't need this one. We don't need this one because now we actually have the target here. But this one we actually need. And then value is, should we call this target? This is the actual target. I guess it doesn't matter. And then we have mutating array result value apply target. That's fine. Emit array mutation. Oh, this is the problem, I think. Okay. Oh my god, he's so... There's crying upstairs. It's hard to concentrate when you have your 4-year-old not in. Updating one. So let's see. Oh, you have to excuse this. We can do another. No, it's still mutating it. Why is it still mutating? So we have immutable target. Immutable target, immutable target. Oh, that one's wrong. Let's try again. Updating 0. Oh, this is 6 and this is... God damn it, what did I do? I have to review this. Value apply. We need a simpler example. Let's see. Let's comment out all of this. Let's see. Function state counter. Let's see. And then return counter, and then we're just going to set timeout. 1 second. Counter.count plus plus. And then we're going to do counter subscription, export default page, counter user, counter subscription return, counter.count. Okay, let's see. Oh, this one is working. So I guess it's the way I handle arrays. Let's take a look. So could it be, let's see. So yeah, what's interesting is that we're just doing a nested set here. Emit set, immutable target slice, immutable target key value. Let's see, is it the emit itself? No, we're firing the subscription. Oh my god, he's screaming. Okay, let's try a little bit more. How can I reproduce this in a very simple way? Well, I guess what we can do, let's just go down to a single one and then try to see if we can figure it out. Wait, sorry, that was the wrong file. So we're just going to take one of them. And then let's just do what we did. It is interesting though. It takes a long time. You see, like just loading initial page, it's quite heavy. Okay, so for some reason, it's not handling the immutability of this thing. So let's first see what it does. Emit set updated. Oh, thanks so much. Updating value, immutable target key. Let's see what happens here. There goes in and updates it, but it's like, and this is fine, right? But what we can do here is console.log. So let's look at the old one. Oops. Okay, updating, and here we have limit 5, right? And then we get limit 6. So we do have oh, I think it's the emit here. So this emit should emit to the parent. Let's see. So yeah, I wonder if it's this thing. So I have, these are includes, yeah. I think this is the problem. Sorry, so this shouldn't be key. This should be index, I think. No, not index. Because the thing is, like, we have to update the parent. So this is like, we're creating the proxy for, yeah, how should I do this? Go ahead, because here we are pushing, sorry, we're not, no, wait a minute, it's not this one, because we're just setting. Emit set, okay. Okay, so yeah, updating value on key 0. Yeah, okay. Let's see. Oh, I might see it. No. This is weird. So the thing here should be 6, right? And it is. And this one should also be 6. But this one should not be 6. I don't understand this. What am I doing? Like, these two should not be equal. Let's get a reference to that one. Then get a reference to that one. That's false. But then 0. Oh, that's also false. But then why is this changed to 6? I am utterly confused. Ah, this sucks. It did change reference, but it also... Oh, I need some more music. But it also mutated. What am I doing wrong here? Let's see. So what we have is we have an array, we have an object in that array. And then inside, so this is where it starts. We're changing value, key value. So this is where it's like changing the actual value on the thing. But before it actually performs it on the mutable object. Oh, wait. I think I know what it is. I think maybe I know what it is. Let's see. But just to explain what actually happens here. So it's changing value to limit 6, right? And then this is fine. It's mutated this thing. But now, I'm not sure what this is. What is this thing? 73? Oh yeah, emit set. And then it goes and it has this immutable version, which is now it updates to this version, limit 6. Right? And then it emits that, okay, we have this new... What is it? Why does it do update value again? To 0? Oh, sorry. Oh yeah, sorry. So this is updating the actual array with this new immutable value. Oh, wait a minute. Is it because... Oh, I think maybe I know what it is. So what happens is that, yeah. So when it moves up and it changes the reference... No, that shouldn't matter. No. I am confused by this. But maybe what I'm even more confused by is why the table doesn't update. Oh, is this a input? Oh, maybe it shouldn't change. Oh, I didn't know it was an input. That's interesting. It should change though, but maybe it doesn't. Sorry, I thought this was like okay, let's change that first. Where's the data? Oh my god. You know what we're gonna do? We're just gonna do come on, reviewer parse int data random index dot reviewer +1. How are we gonna do this? I don't think it updates because it's like it's an input, so it does update, but it's just because of the implementation of the table. So we just need a counting thing. How should we do this? Okay, let's keep this one. And then we're going to change the data random index dot reviewer John Doe plus just to see if things happen. Because this one should definitely update. Oh, this is weird. Why isn't it updating the UI? Oh, maybe this is a React compiler thing. Let's turn it off and see what happens. This was a messy process. Oh, look at that. Looks like I'm sitting inside of the DevTools. That's funny. Oh yeah, look at that. It worked immediately. Okay. Well, not the 5, but this one did. Okay, so this is so this seems to be an incompatibility with the React compiler. This is rough. Okay, so we're gonna add it again. I just want to see where it happens. Data table, table header, table body, table cell, get row model. Oh shit, this is a oh, it's even a draggable row. This sucks. This really sucks. I wonder how this is but it's a nice learning. I wonder how this is gonna affect like ShadCN, for example. When people start applying, like the React compiler is gonna be a breaking thing in the community. There's probably gonna be a lot of stuff that won't work with it. And the question is, should React fix it, the React team, or is it in the hands of the library authors? But what we can do, at least, we can kind of just start looking at it. Just see if it actually even renders the table. What the fuck table? Yeah, so it does render the table. But there seems to be like some kind of optimization around. There's a table header, table body, table row, sortable context, draggable table row, get row. Yeah, so what the hell is this table? Use React table. So I have a feeling that the React compiler has like moved and has moved this stuff. But you know what? There was this thing you could do. No, what was it? React compiler, no memo, use no memo. Let's try that, see what happens. But it's, but at the same time, this is gonna completely break the test, right? Oh, look at that, now it works. Okay, so that was definitely a React compiler thing. But the problem now is it's actually not like it's not compiling the table. So then it kind of loses the whole point. Okay, but we didn't actually need, what are we gonna do with this? But it is still weird though. This shouldn't be limit 6, this first array here. I find that very weird. Because these are two different arrays. I kind of want to figure that one out first while we think about what we're going to do about this. Let's see. So this should not be limit 6. This should still be limit 5. So what does that mean? I wonder if it has something to do with how that's the most mind-bending thing about this, is that when I extract the actual value here, where is the thing? Create subscription. So when I ask for proxy immutable target, it's gonna return the immutable target. Yeah, but I don't understand this. Like, okay, let's again, updating value. Okay, we're just gonna have updating value now. Changing value. Console log. Okay, so what's gonna happen here is that first it's gonna update the actual limit, and then it's gonna update the array itself. So here it's updating the limit, and now it's updating. Oh. No, it doesn't make sense. So what happens here is that it makes a copy of the object and then it updates the limit. That's what's happening here. Emit set. If it's an array, it does a slice. If it's an object, it makes a copy of that object. And then it sets the new value. And then it just emits up. And then, let's see. And then it gets to the actual array. The array sets a new value for the first item. And then as part of that, it has sliced the array and then does the update. And then this is the new array. But now there seems to be a reference. It seems to have happened to the other one as well. That's what I don't understand. Yeah, it's very weird. I'm struggling. I don't understand why these don't show as... dang it. So when I'm changing the first immutable target, like I'm changing a copy of it, so it's technically impossible. The only thing that could happen here is that when I emit up, and then I'm assigning a new array, But that's the thing, like I don't understand this. How can this be changed? mm. It like this code is the only code that runs. And it makes a copy. So like how is it possible? Um, I don't understand. This is messed up. See this? Now it is 5. And then somehow by doing this, I don't understand. I truly don't understand what's happening. Because what happens is it goes here, it sets the limit to the new value. And by returning, and when it does that, it will run. Yeah, it's complicated. It's I'm using a proxy to create an immutable version. So it goes up the proxy tree to create immutable versions of the value. So when I change the limit here, it goes in, it hits this proxy trap. And before it actually mutates the target, it goes in, it does an emit set, it creates an update of the immutable target, which is the object in this case. So now we have a brand new object, and we update the value, and then we emit up the tree, or we call any subscribers. We don't have any for this object, but then it emits to the parent. Do we actually log that? Yeah, emit parent. And then it emits up to the array. Hey, I'm this key. You have to go and change me out, because this is the new me, basically. So when it goes to emit parent, it actually calls emit set again on the parent. So now you're getting, okay, you should change index 0, as we can see here, emit parent index 0 with this new thing. And then it does that. It makes an immutable, it makes a copy of the array. It sets index 0 to this new record, and then it emits again to the actual subscriber, which is in React. And then it logs out this new array. But now the old, no, wait a minute, now it worked. Wait, what was different now? Wait, oh, wait a minute, I think yeah, now it's, wait, what happened there? Oh, maybe because I saved it. Yeah, I think I just saved it and it did a hot reload. But these are different. This is a different array. This is a different record, but it shows the same limit. It shouldn't do that. You know what? We're just gonna do like JSON stringify JSON parser on it just to be perfectly certain. Let's see. Yeah, we don't have to do that. Wait, what happened? Oh, yeah, sorry. Oh, wait a minute. So that indicates at the point where it was consumed, but this makes no sense. Oh, wait a minute. Is it like something lagging behind here? Now it's limit 5. Now it's limit 6. That's correct. Oh, sorry. It's because I did stringify. But when I do this, now it says limit 6. This doesn't make any sense. But when I check them, like, is there... Oh, yeah, sorry. So when I store this as a global variable, this as a global variable, like none of these are equally the same, which they shouldn't be. And the first item here is not equal to the second item here. So how did it become 6? So what I'm wondering is, is this Chrome messing with me? This is so weird. Yeah, it is, but it's not using, like, it's not exposed to React, the mutable state. The only thing that's exposed to React is this actual, like, immutable object I keep updating. So it's just very weird. It's just very weird. I'm not sure how I'm gonna check this. Oh my god. Like, if wait a minute, I'm gonna do something weird. So let's do like 2 seconds. And then let's look at this thing. It's 5, right? But if I look at it again, now it's still 5. Yeah, now it's 6. But what the fuck? Oh, wait a minute. Now I know what we can do. We're just gonna keep a copy. Yeah, so now I know what we're gonna do. So let's put this back to 1 second. Let's go in here, and we're actually gonna keep a reference here. Console.log last immutable target. Oh, did I get a message? Message. Sorry, I just got a message. Last immutable 5, right? This doesn't mutate. You see this? And then we have last immutable. But this has... But what I don't understand is that I'm making a copy of the array. And I'm setting the new value here. Emit parent, key 0. And this is before... This is what I don't understand. It seems like we are mutating... Again, so I'm passing this. This is the immutable, the new object, the brand new object that I'm emitting to the parent. But already here, I wonder what this looks like at the moment of... Okay, I'm going to do one more thing. JSON stringify. Let's just look at it at that specific moment in time. Okay, so here we have limit 5, updating value, firing up to the parent. Yeah, and the array actually has limit 5. And then I'm updating the value. And then I'm updating the value of this new... let's see. Last immutable. No, I'm not spreading. I'm just slicing. Here, this is how I copy the array. Last immutable target. Okay, so we're gonna just do another one of these just to see, be perfectly sure. Or do you have to do like slice 0? Do I have to do slice 0? I think I've had this issue before. I thought I could just do slice. How do I efficiently copy an array? I think I've done that I had that issue before. Oh, okay. Do we have TypeScript there? Java, JavaScript? No, it should, yeah, just slice it. It's weird. It's super weird. Last immutable 5 5, last immutable 5 5. Okay, so it didn't actually change. So it's still... So how can... I have a feeling this is like some internal... Like, I'm wondering if there's like some Chrome thing, because I'm logging out on the same line. Kind of the same thing, but they don't have equal. But it bothers the hell out of me. Like, it wasn't an actual issue with them, but it just bothered. Like, I want to understand why this happens. Because I know that Chrome keeps like you know what? I have a feeling. I think this is a Chrome issue. I just have this feeling that when I console log on a specific line, like the way that like the way Chrome actually keeps a reference to the actual object is maybe it's not the actual object reference. Maybe it's just like, okay, when you console log something, it just keeps a reference to the last console log on the same line. So I'm not actually looking at this object. Maybe it can explain this to me. So I am very confused by some logging by Chrome. I have an array with an object. I console log that array and everything looks fine. Then I create a new array with a new object where I again log on the same line. On the same line in my code. So I have an array with an object that a component subscribes to. I have a state store, an array, and an object that a React component subscribes to. I console log the array and everything looks fine. Then I create a, then I update the store, which creates a new copy of the array and the object. Updating React and logging out on the same line. When I look at my Chrome DevTools, both log statements shows the same array and object, but storing them as global variables and comparing them, their references has changed. Is Chrome doing something weird? It's just when you log an object on array, Chrome logs a reference to that, not a snapshot of its value at that moment. That means the object is later updated. Or you're creating new copies with identical contents. Because the console is showing the current state of those objects. But how can Chrome have a reference to the object where the limit property that I changed was different? How should I put this? So the copy is not identical. I changed the value of a property on the object, but Chrome still shows them as yeah, if that makes sense. It's almost like it could be like some kind of crazy. Yeah. So even though you're creating a new copy, hence a new reference, if you update, yeah, and if you need, yeah, no, there is something happening here. I have to go soon, but I would love to figure this out. Okay, so we're also gonna look at looking. I, this is so weird. It makes absolutely no sense. I'm changing it. I'm making a copy of it, and I'm changing the key to this new value, and this new value doesn't change. Or let's do this. Let's last immutable, and let's look at the value. Does the value stay? Oh, sorry. Oh, let's see. Last immutable. Oh yeah, sorry. This is the actual value. Yeah, this is a bit weird. Or let's keep that one. That's the one I wanted. I want to know what is the thing that's actually changing. Is it the array or is it the actual? Yeah, you see this? So the last immutable inside the object, that's correct. That's number 5. But the last immutable, it's almost like the slice isn't working. Like, does it identify it as an array? Wait a minute. Is it the is array that's wrong? Maybe it's doing this thing and something goes wrong. Last immutable. No, it is an array. Then how can this change? How can this change to limit 6? I made a copy of it. But that would mean this value is already okay. So we're gonna do another one. We're gonna do okay. So the problem is at the point of the array. So if is array, if is array, we're only gonna log that. So what we're gonna log is the value as it comes in here. JSON stringify value. And then value, and then we're going to keep a reference to the value. Okay, let's look at this. So we're updating. Oh yeah, where was that updating? Yeah, we don't need updating. Okay, so we have last immutable. Oh, it's already changed to 6 here. Oh, this is interesting. This is very interesting. So at the point where I'm receiving the value, no, but that doesn't matter. No, sorry, that doesn't matter. So I'm receiving the value with 6, that's correct. But I made a copy of the array. Which means that when I perform this, I'm performing this on the new copy of the array. So the old value is untouched. I'm gonna add a 0. I just have a feeling I had this issue before. No, it's not that one. God damn it. What's happening here? Okay, so what we're also gonna do here, yeah, we're gonna do another thing. We're gonna go into the last immutable. We're gonna just look at the object there, because this should definitely not change. So here, last immutable. Sorry. Oh, but it does. What? But this is 5 now, right? This is the weirdest thing. Yeah. How the fuck does this work? I'm replacing it with a copy of the array. And last immutable equals immutable target. That's false. And last immutable 0 equals value. That should also be false. Yeah, false, false. But still, when I look at the thing, it's changed to 6. But I'm not sure if this is actually true. That's the problem. And it doesn't really matter. Yeah. Ah, this is so weird. Yeah, I have to go. I have to go. This sucked. But anyways, the most important thing is to actually be able to test this compiler thing. So we need to find another table that actually works with the compiler. And we can just wield our own table. We could kind of reuse some of the components, but not use that like use React thingy. And then we can see how it performs. But this is bothering the hell out of me. There's something really weird going on. And I don't think it is... What the hell? Because this is gonna show 5. Yeah. I have a feeling that it's Chrome. There's something that Chrome does. Yeah, maybe we should ask Claude instead. Oh. Oh my god. Like, yeah, to even start looking at this, I have to kind of go away from the implementation and just purely like do immutable objects and just log it out and not have all these proxy stuff around it, just to see what happens. But I don't have time for that now, so I have to stop the stream. God damn it, this sucks. I could sit with this all day. But yeah, I'm not sure when I'm able to actually look at this. Yeah, I'm gonna do when I get a chance, I'm gonna do an experiment, isolated experiment, just to see if it's Chrome or what it is. Because at least if the same happens when it's like super simple, then it's definitely Chrome. It still sucks though. But maybe Chrome is... Yeah, I'm just wondering if Chrome has like... No, it should have a reference. It does have a reference to the actual array. Ah! But it also sees that I changed the references, like when I store them as global variables. And even inside the code, like I'm looking at the last immutable target, right? So even if I do this, immutable target, like this is really the test. So I want to conclude with like, and there is nothing else updating these things, right? Okay, last look. So just to conclude, this last immutable, this is the old one. For some reason, it's showing the new object there. But that is technically not possible without that actual value updating. Oh, wait a minute. Okay, so one thing I'm wondering is, so what happens after? So when I do reflect set target, this is gonna change the underlying target. But that's also what I don't understand, because I'm making a copy up here as well. So there is no correlation between the immutable target and the actual target. But that would have made sense. Like, so when I actually change the limit, I emit like the immutable thing up, but then I do actually mutate that object, that underlying object. But the thing that's being emitted up is the immutable one. It's not the actual. I have a feeling that I still have like some target reference here that I'm like emitting up. But I can't see it. Like everything is immutable target. But that would have explained it. Because then I would like I would have kind of emitted the immutable thing, but then at the end of the day, it's actually going to perform that mutation on the original target. Oh, could it be? No. Yeah. Could it be like a closure? This one's also interesting. Because this creates... Oh. That could also... Oh, I'm going to try one more thing. We're going to do this. And then let's see what happens. Oh, no. Okay. No, I'm going to isolate the issue. Not have all this proxy stuff. Just do very, very simple thing. And then see if my suspicions are correct. Yeah. And just fix that, because this is a really cool way to expose mutable state to React by basically doing mutations in your state store, and then everything's immutable as you expose it to React. And then apply the compiler to see how fast it can really be, and then make some conclusions based on that. Cool. Thanks for following along. I have to be an actual family person, so bye for now.